The power rule for differentiation allows us to find the derivative function or gradient function of functions looking like this one here. F of x equals to 3x to the power of 5. Looking at this function, we can see that what we're dealing with is a power of x, that's x to the power of 5, and it's all being multiplied by some number, in this case 3. Now as soon as we're given anything like that, we can find the derivative function with the power rule, which states the following. If a function f of x is equal to a times x to the power of n, then its derivative function, f dash of x, will equal to n times a times x to the power of n minus 1. This is known as the power rule for differentiation. So let's see how it works. Comparing our function here, 3x to the power of 5, to the generic function a times x to the power of n, we can see that a is equal to 3 and n is equal to 5. And so since the derivative function f dash of x equals to n times a times x to the power of n minus 1, we'll have f dash of x equals to 5 times 3 times x to the power of 5 minus 1. That's f dash of x equals to 15 times x to the power of 5 minus 1, which is 4. And we're done. We now have the derivative function. Now, when studying calculus, this power rule is quite simply unavoidable. So do make a note of this formula if you didn't know it already. Okay, we're going to work through 3 more examples, and do take the time to watch these, as I've chosen them to make sure that for each one of those examples, we learn something new. As a second example, let's say we're given the function f of x equals to x squared, and we need to find the derivative of this function. Well, looking at this function, we can see that x is raised to the power of 2. In other words, we're definitely dealing with a power of x here. So to find the derivative, we can use the power rule, which remember stated that if f of x equals to a times x to the power of n, then the derivative f dash of x will equal to n times a times x to the power of n minus 1. Now, comparing the function we have here to the generic function f of x equals to a times x to the power of n, we can see right away that n, in this case, is 2, but we don't necessarily see what a is. Well, it's important to remember that when we write f of x equals to x squared, we can think of this as 1 times x squared. And now we can see right away that a is simply equal to 1. So to use the power rule, we have a equals to 1 and n equals to 2. Now that we've done that, we can go right ahead and use the power rule formula to find the derivative function. And we can state that f dash of x will equal to 2 times 1 times x to the power of 2 minus 1. And that's equal to 2 times 1, which is 2, times x to the power of 2 minus 1, which is 1. And we could stop there, although we never actually write x to the power of 1. Indeed, it's worth remembering that when we write x to the power of 1, it's simply equal to x. So we should write our final answer here as f dash of x is equal to 2x. And that's the final answer. Let's look at the third example. Say we're given the function f of x equals to 5x. And again, we need to find this function's derivative function. Well, looking at this function, one may not see right away that we're dealing with the power of x. But in fact, we can think of this function as f of x equals to 5 times x to the power of 1, since x to the power of 1 is equal to x. And we can now see quite clearly that we can use the power rule, which remember states that if f of x equals to a times x to the power of n, then its derivative function f dash of x will equal to n times a times x to the power of n minus 1. So comparing our function to the generic function a x to the power of n, we can see that we have a equal to 5 and n equal to 1. And so, using the formula for the power rule, we can state that the derivative function f dash of x is equal to 1 times 5 times x to the power of 1 minus 1. And that's equal to 1 times 5, which is 5, times x to the power of 1 minus 1, which is 0. And although we could stop here, we really shouldn't. X to the power of 0 is equal to 1. Indeed, for all non-zero x, we have x to the power of 0 equals to 1. So this derivative function is in fact equal to 5 times 1. In other words, f dash of x is equal to 5. And that's the final answer. This result can actually be generalized for any function looking like f of x equals to 5x. And we can actually write, if f of x equals to a times x, that's some number multiplying x, then the derivative function, f dash of x, will always equal to a. That's the number multiplying the x. So for example, if we have f of x equals to 7x, then its derivative function would be f dash of x equals to 7. Or say we have f of x equals to 3x, then its derivative function would be f dash of x equals to 3. And even f of x equals to x, then its derivative function would be f dash of x equals to 1. Now, as you can see here, it's worth making a note of this special case. When the power of x is equal to 1, we can simply get rid of the x altogether when we differentiate. Okay, let's look at the fourth and final example of the power rule in which we introduce a different notation. Say we're given y equals to 4x to the power of 3, and we're asked to find the derivative function. Since in this case we're given the equation of a curve y equals to 4x cubed, it's worth introducing a new notation. And that looks like follows. If y equals to a times x to the power of n, then its derivative, which is written dy dx, is equal to n times a times x to the power of n minus 1. And just to be clear, this is exactly the same power rule as the one we've just seen. The only difference lies in the notation. And it's very important to realize that whether we write f dash of x or dy dx, we're referring to the same thing. That is, the derivative function. Nevertheless, you do want to make sure that you're familiar with both of these notations, as either one of them could appear in an exam question. Now, back to our function, we have y equals to 4x cubed. And we can clearly see here that we can use the power rule. And comparing it to the generic y equals to ax to the power of n, we can see that a is equal to 4 and n is equal to 3. So, using the power rule, we can state the following. The derivative function dy dx is equal to 3 times 4 times x to the power of 3 minus 1. And that's equal to 3 times 4, which is 12, times x to the power of 3 minus 1, which is 2. And that's the derivative. And there we have it. That's how we can use the power rule for differentiation for finding the derivative of a function. There we go, everyone. I really hope that helped. And if it did, please hit like on this video and even subscribe to our channel, because that really does help us. I'll see you soon.